All right, ladies and gents, let's take a look at Lesson 19. Lesson 19's question of the day: how can programming help make complicated problems more simple? So in this lesson, you'll learn about collision detection on the computer. We're going to work in pairs as much as possible, but given our quarantine standards, we might not be able to. We're going to explore how a computer could use math along with sprite location and size properties to detect whether two sprites are touching. We will then use the touching block to create different effects when sprites collide and practice using the block to model various interactions. The vocab word for this lesson is abstraction. Abstraction is a simplified representation of something more complex. Abstractions allow you to hide details to help you manage complexity, focus on relevant concepts, and reason about problems at a higher level. We've got two new pieces of code here. It is sprite.isTouching target and sprite.debug. So let's get going. All right, so dinner time. Run the program to see the robot bring the bunny dinner. When the bunny reaches the bowl, they both stop walking and the bowl becomes empty. What code do you think would help the computer know if two sprites were touching? So let's hit run and see what's going on. Bam. Okay. Well, what do you think would help the computer know if the two sprites are touching? Think about what they share here. Got any ideas? Hopefully you do. Let's see what's next. Da-da-da! Level 3, using math to figure it out. Computers use math to figure out whether two things are touching. Look at the math on lines 17 and 18 of this program to see how the sprite properties are compared with their width to see whether they are touching. Do this. Read the if statements inside the draw loop and find the different sprite properties and how they are compared. Discuss with your partner, if possible. Why does the code only use the width and x properties and not use the height and y properties? And would you want to write this code every time you checked whether something is touching? My guess is you probably wouldn't. So let's see what we got going on here. We've got a backdrop, a bunny. Bunny's velocity x is set to 3, so the bunny's going to be moving to the right. We've got the robot. Robot scaled down a little bit. Robot velocity is -3, which means it's going to be moving to the left. We've got dinner. Dinner is set to stew, and the dinner velocity is set to -3. So we're told to look at lines 17 and 18. Oh my. All right, function draw. If bunny x is greater than dinner x and bunny x is subtract dinner x is less than bunny width divided by 2 plus dinner width divided by 2. Holy moly, that's a lot of math. And see line 18. Wow, bunny.x is less than dinner.x, and bunny.x is subtract dinner.x is greater than. Wow. Stop everything and change to empty bowl. Then it says bunny.velocity x equals 0, dinner.velocity x equals 0, robot.velocity x equals 0, dinner set animation to bowl. Holy moly, that is a lot of math. Wowzer. Okay. So, why does the code only use the width and x parameters and not the height and y parameters? Well, I think the code uses width and x because they are moving left and right, not up and down. So what will touch is the width and X values. That's my guess. Would you want to write this code? Heck no, I would not want to write this amount of code every time. Exclamation point. All right, so let's see what's happening here. Run. Come together. Bam, they stop. Okay, so let's move on. I'm hoping, fingers crossed, that we don't have to write that amount of code every time. That's a lot of code. All right, level 4 is touching. Writing out the math each time you want to check whether two sprites are touching can take a while. So a programmer created the is touching block, which can check whether one sprite is touching another sprite, the target. The computer is still doing the same math as in the previous program, but you don't have to worry about it because another programmer already did that work. Boy, thank goodness for programmers. Do this. Inside the draw loop, drag the is touching block into the if block. Hint, don't forget to change the sprite to bunny and the target to dinner. All right, show me where. Sprite to bunny, target to dinner. Add your block here. So that's the is touching. So bunny is touching the target, which is dinner. Okay, it's bunny touching dinner. Let's see if it works. Beautiful. Man, that is so much better and nicer looking. Thank you for that is touching block. Let's see what happens at the next level. All right, so applesauce. The blender should only turn on when the apple touches the target. Do this. Use the new code you learned to check whether the blender is touching the apple. Use a conditional to only shake the blender when the apple is touching it. Hint, you will need to drag 2 blocks into the workspace. I bet you we're going to use the Y value this time. Okay, so got an apple and a blender. We've got blender X equals 200 plus random number for Y. Make the background, and then the draw sprites. So what did we do last time? Last time we had an if statement. So we said if what? If sprite is touching target. So if blender is touching apple. It might be backwards there. It might be if apple's touching blender. Let me try it that way. Because it feels like if the apple's falling, if apple's touching blender. I wonder if it matters. If apple is touching blender, then what do I want to happen? Then I want the blender to shake. Right? And so let's see if I'm right. Let's see what happens. Woohoo! It worked. All right, so what happened? Well, if apple is touching blender, then blender.x equals 200x and random y position. So it worked. Let's hit finish. Da-da-da! Debugging collisions. The balloon is popping before the tack touches it. You can use the debug block to get more information about the bug in the program. Do this. Run the code and use the arrow keys to move the tack to pop the balloon. In the code below, change balloon.debug equals false to balloon.debug equals true. Add a new debug block to the code and set the tack sprite debug property to true. Sprite tack. Run the code again and discuss. Okay, let me run. Moving the tack. Boy, it moves off. Oh my goodness, it popped already. I wasn't even close. I go down, I go over, pop. All right, so let's start here. Got a variable balloon, balloon debug false. Let's say true. Run and see what happens. We look down here. So something tells me debug sprites on. Reset and run. No, that didn't matter. So what if I do the tac.debug true? Let's see what happens here. Okay. So if balloon is touching tac, then balloon will be popped. If key down, tac moves down. If key up, tac moves up. Down moves down, left moves left, right moves right. Okay. Alrighty, so then let me check the directions again. Run the program, use the code below, I did that. Add a new debug block to the code and set the tax property to true. Did that, run the code again, then discuss. All right, so I think what's happening here is those squares around the balloon and the tac, see, once one square touches the other square, then it's popping. Look at that. So it's almost like this natural space around the balloon. And that's really it for this level. It's just kind of trying to figure out what's going on and how to use that debugging block. So I think this area around our balloon is too big. I don't know how to fix that, but I think it's too big. All right, let's hit finish and move on. Alrighty, let's do letter A. Debug is touching. Debugging practice is always good. Problem solving is important. All right, debug is touching. The bunny sprite should change to a new animation when it touches the sun sprite. Figure out why the bunny doesn't react to the collision. Do this. Modify the code so that the collision is detected with the draw loop. All right. Hit run. Poor old sad bunny. Angry sun. They touch. Nothing happens. Okay. We got the sun, we got the bunny. If sun is touching bunny, bunny set animation to bunny happy. Is it because this whole thing is not inside the draw loop? Perhaps. If sun touching and then the sun velocity, maybe. Let's see if I'm right. Sun is falling. Yep. Bunny happy. Yay, it works. That was easy, just moving some code. Remember those if statements got to go in the function draw loop. Alrighty, if you want to do the other one, I'll give you some bonus. Otherwise, hit finish. Let's look at your assessment level. See what kind of hints I can offer. Rainbow horse? Oh my. When the rainbow touches the horse, it should turn into a unicorn. Do this. Add code that changes the horse's sprite appearance into a unicorn when the rainbow touches it. Oh my goodness. Okay, you got a horse, you got a rainbow, you've got a function draw, says draw the background, you've got that. And it says change the horse to a unicorn when the rainbow touches it. So here's some hints. You're going to need an if statement. You're going to need a sprite is touching target. And then because you want to change the horse into an unicorn, you're going to need a dot set animation. Okay? Good luck with that. And then last but not least, the challenge level. Ooh, you got 3 options here. Collider at an angle, improve collisions for sprites with angled animations, or debug, add points on collision. Ooh, so both of these are going to be super cool if you try them. Learning how to add points on collision. I bet that would come in handy for your lesson 27, designing a game. All right, folks, that's it for lesson 19, collision detection. Have fun with it, and I will see you soon.